Good afternoon and welcome back to the education track here at PyCon 23. For this next session, I'd like to introduce Thea. Thea is a high school teacher, maths, digital technologies, something else too, wasn't there? No, those two. She works in Brisbane at the Kelvin Grove College, and from what I've seen at Kelvin Grove, they have a really good digital technologies program. I know Thea is passionate for women and being a bit of a mentor with getting girls coding, very important. And I'd like you to put your hands together for a Pythonista of coding. Thank you.
Thank you. Sorry. All right. Hi everyone. I'm Thea Koutsoukis, Theosaurus, a digital technologies teacher up in Meanjin, Brisbane, and I work in a large state college, which I love. I'm a great believer in the power of state schools, but it does mean working within the most restrictive internet filter ever. No student access to GitHub or any code repositories, project management tools, the Google Suite, most cloud services, and it was only last year that you could apply with principal permission for the ability to download Python libraries, the most dangerous thing of all. So I've taught digital technologies and mathematics at all high school levels, and I'm lucky enough to have a great deal of control over what I teach. So although Haskell was my first love, Python quickly became the tool that I turned to for my own projects. And when I became a teacher, I found it was such a fantastic language for education. There are so many great Python resources and tutorials out there, and I appreciate that the syntax is close enough to pseudocode that my Year 12s can just about use it on their external exams. I love that I'm able to use Python across so many different contexts, from beginner text-based scripts to scientific and mathematical modeling, AI, game development, GUIs, physical computing, robotics, and web development. And I think that having that common language really helps reduce the cognitive load on students when you're throwing in SQL and databases, user interfaces, usability and design, HTML and CSS, and everything else that we expect of our students. So in Queensland, digital technologies curriculum is mandated from prep to year 8. However, you only have to teach it for a suggested semester once per band of 2 to 3 years, which means that a student might do a bit of digitech in year 1, then again in year 4, maybe some robotics in year 6, and then they start high school and they have no idea what digital technologies is all about. At my school, I work in the middle senior space. We get to access our year 7s for a total of 3 weeks, once a semester, in which time we try and cram in making an arcade game using Arcade MakeCode, which is a simple platform that has the option for block coding. And then from then on, it's an elective. So in year 8 and 9, students can choose to do digital technologies for a semester. We look at things like computer hardware and networks. We do some basic programming with robots. At the moment, we're trialling micromelons, which are these little robots with a bunch of sensors that are programmed in Python. And they have a virtual simulator that helps alleviate the problem of not having one robot for every student. We do a unit on building a text-based chatbot in Python, making use of some of the free Grok resources. So thank you for that. In year 9, we introduce students to web development, creating static websites in HTML and CSS about an artificial intelligence project that students can then submit to the Microsoft Imagine Cup. We take students through design thinking process, finding problems, designing applications with users in mind. We start to introduce databases and SQL, doing some work around data security and privacy. Then in year 10, we get a whole bunch of new students who've never done it again. And we start with game dev to try and get them hooked. We've been going with Godot lately, which uses a language that's really similar to Python, but after this morning's talk, maybe I'll consider Pygame 0. And we start to build on that SQL knowledge and get into physical computing with Raspberry Pis. At the very end of the year, we start to introduce web applications and APIs, building simple web apps that get data from space APIs in JSON and then display it on a website. And in year 11, we officially start the senior subject, which in Queensland is called Digital Solutions. The syllabus assumes that students have done digital tech only up until year 8, so it starts right back at the beginning, learning to code. But we have such a short time frame to teach it that it ends up actually being quite challenging for those students who are new to the subject. And an interesting quirk of the Queensland syllabus is that it requires students to be creating user interfaces right from the start. As we saw in the earlier talk about Pygame, this is a big ask. I've been using PySimple GUI. It's a library that's basically a nicer version of tkinter, but students get a bit frustrated with it, so we get then into web applications, combining Python with HTML and SQL, which we continue all the way until the end of year 12. So at every stage, we get students joining the class who've never really programmed before, along with students who've been doing it all along or as a hobby in their spare time. So it's really challenging designing lessons that work with beginners, but don't bore experienced students. So let's talk web apps. I didn't touch web development at uni or in my previous job as a junior developer, but I did do a bit of HTML and CSS back in my Neopets and MySpace days, but that was mainly copying other people's styles rather than creating my own. And it wasn't until I went to a Django Girls workshop in 2015 when PyCon was up in Brisbane that I was introduced to web applications, websites with a back end that you could program. But I found Django quite overwhelming, to be honest, and although I was able to copy the tutorial, I didn't understand most of what I was writing. But a few years later, I became a teacher. And when the new Queensland Senior Syllabus was released, there was encouragement to use a web development context for at least one of the units. So I looked to Python for options. I found that a lot of the full stack frameworks, like Django, while obviously robust and fully featured, were a bit too complex for my liking. My students don't need an admin panel or to use a professional database server. I needed them writing raw SQL, not using an object relational model or ORM that converts the data relationships into object-oriented classes and methods. I didn't need all batteries included. I just wanted something lightweight and easy to learn so that my students could create something amazing in just a few weeks. Like Jack said earlier, I wanted minimal boilerplate or cruft. So I turned to Flask. Flask is a micro framework. It has no database abstraction layer, no inbuilt form validation, and very minimal boilerplate code. This on the screen is all you need to start a Flask server and display a web page that says "Hello World." In JetBrains' annual Python developer survey, Flask came in as the top web framework used with 41% of the vote. And what really helped is I found this fantastic series of blog posts by Miguel Grinberg called the Flask Mega Tutorial. And I highly recommend these as a beginner project for a teacher to learn the basics of Flask. However, it does have some downsides, namely that he uses an ORM called SQL Alchemy instead of the raw SQL, which is what I need to assess my students on. So to run a Flask application, you open a terminal, navigate to the project folder and type Flask run. So from there, I developed a template for a basic student Flask project. And today what I want to do is take you through this template and explain what you need to do to get started on your own Flask projects. And I'll show you some examples of student projects that we've done and cool libraries that we've combined with Flask. So this is the basic structure of a Flask project. Inside our root directory, we have the app folder. Now you don't need to call it app, but every example online calls it app. It's the default application name, and it allows you to use the shortcut to make it just Flask run when you run the app. So I like to keep it as app. Inside app, we have our static folder that contains any of the CSS and JavaScript files, images, videos, any static content that we want to display on our page. Then we have the templates folder. So templates, Flask looks for HTML pages in a folder called templates. So it's important that it's named correctly. So let's go through the actual Python files. We've got init.py, db.py, roots.py, and config.py. So what is init.py? I chose, when developing this template, to split the code up into init.py and put all of basically the code that's necessary to get Flask running, but that students don't necessarily have to be able to write and understand. So it initializes the Flask app, the database, if you're using one, and the login manager if you're dealing with user logins. So that pretty much stays the same for every project. Then we've got db.py. It's another file that students will use but not necessarily have to understand. It defines all of the functions for creating a database from a schema.sql file and for connecting to and disconnecting from the database. We've got config.py, which contains configuration options like the name of the database. I also get students to put their school username and password there if we're working with APIs and need to connect through the school proxy, because that way they can keep that file secret out of any code repositories if they're using them, and they don't need to include it in their assignment submission. The last thing we have is roots.py. That's the meat of the program, where students will be writing all of the Python code. So what goes in roots? Well, if we look at a structure of a URL, we start with the protocol, then the domain, and then the individual paths. So these paths are what we define in our roots.py file. To define a root, you can see I've got some code here. We use the app.root decorator, and then we list the root. So you can see this first one is just slash, so it's basically the home page. And then I've got a further page that is /test. So if you went to your website /test, it would deliver the code that's under that decorator. So once you get into more complex applications, you can use variables within these path names. But to be honest, I haven't had to teach that for any of the assessment I've given so far. So just having those simple roots it has been enough. But I have found that if you use something like, when you're teaching /test, then in the assignment, everyone will just use /test, even though it doesn't make sense to the context of their assessment. So here we see the typical flow of code. You create a root that renders an HTML page. In this example, I'm rendering index.html, which inherits from base.html. So this ability to inherit from a template, so to put, all of your base code and then have different pages that inherit from that, is through a library called Ginger that comes pre-built with Flask. It allows you to do things like define a HTML page that's just for the footer or for the nav bar, and then you can insert that into your different pages. But to be honest, after reflection, I think it's a bit too much for students. They don't tend to understand what we're doing with the templates, so I think I might remove that in my next version of the template. But Ginger is useful for other things. It allows us to insert variables from our roots.py file and also do a bit of code. So here you can see, it can do things like if-else statements and for loops, and the syntax is very similar to Python. So you can see here, I've got a list of indicators. It's a variable called indicators, and I'm looping through it for each indicator code in indicators. And then I'm creating a drop-down menu. That's the select and the different options of the options in my drop-down. And the value of that is going to be that indicator code. And I'm also, as the text that will appear, I'm inserting a variable with those double curly brackets, and accessing a particular index of a list using the square bracket notation, just like you do in Python. And this all comes pre-installed when you get Flask. So then we deal with databases. So to create a database of your own, you can define the create table statements using standard SQL in a schema document. The default database language is SQLite. The upside to this is that it's a very easy version of SQL to learn. There are only like 5 data types and there's no crazy functions. The downside is that it doesn't deal well with making changes to your database structure. It's almost always easiest to just delete your database and recreate it when you're working with student projects. Of course, if you type in flask init.db, then it will initialize the database. It will create a new database according to that schema with whatever name you've chosen in your config file. And of course, if you're working with a pre-existing database, you can just skip this, place the database into your root directory, and not bother with a schema document. So how do we interact with databases? Well, you can see here at the top with my import statements, I'm importing from app.db. That was that db.py file that we had back in our app folder. And it has a function called getDB, which gets the database. So you can see I'm calling that function, I'm setting it equal to a variable that I'm just going to call db for simplicity. I'm then going to execute an SQL statement, select all from category, and then I'm going to fetch all of the results. You can either fetch one result, which is basically select all from category limit 1, or you can fetch all of the results. And I'm saving that in a results variable. And then I'm closing the database and I'm passing that results into my categories.html web page. So it's really easy to pass variables from roots.py into our HTML pages through Ginger. And then we can refer to it using Ginger. So we just put those results into the HTML page. And we can also use variables in our SQL. So in this example, I'm getting the country code from an HTML form. So how do I do that? At the top of my root, where I've defined the path, I've said that the methods that are allowed are get and post. So the default is just get is allowed, and if you don't say that you can do post requests, you'll get a forbidden error. And because I'm using this same root to both display the form and display the output, which in this case happens to be, it's going to be a graph, I have an if-else statement that checks whether the user has done a post request, whether they have picked a country in the form, or else it just sets it to a default of Australia. And what's cool is that it's then going to take that country variable and it's going to insert it into the SQL statement using a question mark. So you can see in my SQL, at the end of the line, I've got and country code equals question mark. And then when I execute the statement, I'm going to say, I'm going to execute that SQL statement and I'm going to pass in country as the variable. So you can have multiple question marks as well, and then instead of just country, it would be country, comma, and then whatever other variables you want to insert in the same order that the question marks are in. It has to be a tuple, which means that it's kind of weird if you have just one variable, you have to put a comma after the word country. That's the thing that always trips up students. And this method of inserting variables, rather than just doing country code equals and then plus country, this method protects against SQL injections, which is always a nice thing for my students to be able to write about in their evaluation of the security of the system, like they have to do in Year 12. Of course, you don't just have to query databases, you can also insert new values. After you execute the SQL statement with the insert, you just then need to commit those changes. So let's look at some fun libraries that I have used with Flask in the last couple of years. We've used Plotly for making beautiful graphs, requests for doing API requests, Flask login for building login systems, authentication systems, and cryptography as well. So this term, my Year 11s did a project using an existing database from the World Bank. So I went and pulled CSV files that were on the World Bank website that collect data about every country in the world with all these indicators across, social, education, governance, really interesting stuff. And I put them into an SQLite normalized database, relational database. And their task was to turn data into wisdom. So they had to search the database to find something that they were interested in. We got some really interesting student ideas, like looking at various indicators for countries before and after there'd been civil wars, or looking at at all the indicators that were around women and what that looked like in different parts of the world. So students used HTML forms to get user input. They inserted it into an SQL statement and they graphed the results using Plotly, and this was displayed on the web page. So what does the code for something like this look like? This is a slightly smaller example because I couldn't fit it on the screen. But this was a student who was creating a map. So they had this great big SQL statement, joining tables, multiple where statements, and they executed the SQL statement and then loaded it into a pandas data frame, which basically all you're doing is putting in the results and then saying what you want the different columns to be called. And then creating this graph. So this one was px.choropleth. It's a type of map graph, but you can, if you wanted to make it a line graph, you would just change it to px.line. If you wanted it to be a bar graph, px.bar. And then you put that data frame into the function, and you say what you want some of the variables to be. So if you're looking at a line graph, it might be, what do you want the X and Y axis to be? In this case, because it's a map, I wanted the locations to be the country codes, because it turns out just putting in the country codes that were in the World Bank database works perfectly with the Plotly map. So they could actually generate maps of the world, coloured, with the different values for this life expectancy statement, which was quite cool. Then it does just a little line of code to turn it into a JSON object, which you pass into your HTML page, and then a little bit of code, a little bit of JavaScript, just a few lines that then graphs it on the page. Here's another project we did, a Year 12 project from last year, a mock application for an industrial warehouse that needed to keep its workers working in safe temperatures. So students attached a temperature and humidity sensor to an Arduino and then output the results as a JSON object that got read by a Python program and put into a database. And then they created a web application using Flask that read the most current temperature results from the database, along with the temperature from a Bureau of Meteorology API for external temperature, and then it changed the user interface to an alert if the internal or external temperature was too high. Students also created a page in which users could change what that safety threshold was. So we used the requests library. Here you can see I have my requesting my URL for the Bureau of Meteorology API, which they don't want us to use, but it's really cool. And then I'm doing a GET request, and I had to put in proxy information because we're behind a school proxy, and then loading it into a JSON file. Another project we did was around security, creating a sign up and login page and then hiding certain information behind a login. So the context for this one was the Australian Defence Force was storing data about how many military personnel they had in each city. And the city data came from an API, and then the military data was entered by users and encrypted in the database. So we used the Flask login library to do things like, create safe logins, and we use the cryptography library to encrypt things as well. So basic unit structure of how I teach Flask. It is assuming that basic knowledge of Python. We go databases and SQL, then intro to Flask, getting it all working, creating a basic root, intro to HTML and CSS, then combining Flask and HTML, putting variables in, combining it with the databases, and then doing user input. So this is my information. GitHub currently has that base template, if that's something you're interested in, and I'm also working on committing some sample projects using those different libraries as well. And that's me. Thank you.
Thank you so much, Thea. Here is your little cup and your thank you card. And so I think that was amazing. Do we have any questions in the audience? Yes.
So how have you gone with students understanding cryptography, the library, and also cryptography as in what it's actually doing?
Yeah, so cryptography is it's in the syllabus as in the Year 12 senior syllabus, starting with, Caesar cipher and going up to kind of more modern cryptography things. We really just use the function in the cryptography library .encrypt, and we don't really get into the specifics of how that particular cryptography method is using. And same with the logins, with hashing passwords. There's just a function, generate password hash, and same for checking password hashes as well that we use. So we don't get into the nitty-gritty of how the cryptography library works, but we do talk about cryptography, different cryptographic algorithms, a little bit of the theory behind it.
I suppose it's a question about how do you teach SQL, how you introduce it to students, and I'm guessing you're using VS Code. Have you experimented with ways of highlighting syntax for SQL? Because I find just the red string and the error messages are not super helpful quite often.
Yeah, so I actually don't use Visual Studio Code. I just used it because it was pretty for this. I use PyCharm just because it makes it really easy to install Python libraries behind a school proxy. The way I teach SQL, I do it separately through a GUI at the start. I use DB Browser for SQLite, and there are some really good resources. SQL Bolt has really good lessons for practicing and teaching SQL. Yeah, I guess it's hard to explain how you teach something. Yeah, I have steps. I mean, students have most of them have done a little bit in Year 9, a little bit in Year 10, and so by the time, they're kind of repeating it, and, SQL is does what it says. It's very English friendly, I think. Yes, I do SQL by itself, and then we jump into SQL plus Python. Yeah, good question.
Just still on SQL, you were talking about just minimal data types. Are objects supported? Can they have a database of images?
Yes, you can put blobs, I think is the data type they call it. Yeah.
All right. Can we
you.
give Thea another round of applause, please?